A very good morning all of you. So in today's class, let us start with the solving some numericals on non-inverting amplifier. In previous class, if you remember, I had taught you all solving of numericals on inverting amplifier. Let us apply the same techniques and let us now solve some of the non-inverting amplifier numericals. The first one, design a non-inverting amplifier using op-amp with a closed loop voltage gain of 10. So what is this closed loop voltage gain of 10? Which means value of AF is mentioned. R1 is not given, RF also is not given. Only value which is given is the closed loop voltage gain. Now what is the gain of an non-inverting amplifier? The closed loop voltage gain of a non-inverting amplifier is AF is equal to 1 plus RF upon R1. We had solved this derivation in the previous class. If you want, you can refer to that. So what is AF is equal to? AF value is 1 plus RF upon R1, which has to be equalized to the value for 10 now. So 1 plus RF upon R1 is equal to 10. This one, if we take on the other side, we will get the value RF upon R1 is equal to 9, which is 10 minus 1. So if RF upon R1 is equal to 9, then what is RF is equal to? RF is equal to 9 times R1. Then RF value and R1 value both are not being given. That is why I had told R1 value, which has to be smallest, can be assumed. Then you remember, then we have considered R1 value as 1 kilo ohm in the previous numerical of inverting amplifier. Likewise, we will here also consider the value for R1 is equal to 1 kilo ohm. Let us substitute the value here. Then we will get the value for RF as 9 kilo ohms. So this is the answer. Now that we have designed, we should now substitute the values. This design will indicate that we are supposed to draw the circuit diagram and we should be putting up the values of the entities that we have found. So this ends the numerical. Let us now go to the next numerical, which is for the circuit shown below, calculate the output voltage for the following input voltages. These values which are given are the input voltages. We are supposed to substitute these in a numerical to find the output voltage V0. Unlike the previous example, here the circuit diagram is already being mentioned, in which we are supposed to consider these values for R1 and RF. R1 value is given as 120 kilo ohms, RF value is given as 360 kilo ohms. First, Vi value is given, V0 has to be found, but in order to find the value for V0, we will need other entity which is called as, or other parameter which is called as AF. What is the formula for AF? AF formula is 1 plus RF upon R1 for non-inverting amplifier. We know the value for RF, we know the value for R1. Substitute both of these in this equation, we will get the values. AF is equal to 1 plus 360 kilo ohm divided by 120 kilo ohm. The answer is 4. So now value for AF is 4, which means now we can consider the value for Vi. We already have the value for AF. We can find the value for V0. Let us try to find it out. What is the formula? AF is equal to V0 upon Vi is the formula, which means gain is equal to output voltage upon input voltage. So here we are supposed to calculate the output voltage. That is why V0 is equal to AF into Vi. Let us put these values and try to solve the numerical. So what are the different values for Vi given? The first value for Vi given is 0.5 volts. So what is the formula? V0 is equal to Vi into AF. So what is the value for Vi? 0.5 volts. What is the value for AF? 4. So 4 into 0.5 volts will give us 2 volts, which is the answer. The next parameter that they have mentioned as Vi is 0.6 cos 3140 volts. As I had already told you, this cos 3140 volts can be ignored. Only thing what you should calculate is the 0.6. So now this 0.6 has to be multiplied with the value for AF, which is nothing but 4. So 4 into 0.6 will give me 2.4, and this remaining cos 3140 volts. So answer is 2.4 cos 3140 volts. Likewise, you can solve for the next Vi value and get the answer for V0. The next numerical. So what is the next numerical? For the circuit shown below, calculate closed loop voltage gain, which means AF has to be found and the required input voltage to get an voltage of 4 volts, which means output voltage is being mentioned. You are supposed to calculate the input voltage. The circuit diagram is already being given in the numerical. Here there are two different resistance values given. One is 100 kilo ohm, one is 10 kilo ohm. In this kind of numericals, you should keep one thing in your mind. The largest value will stand for RF and the smallest value will stand for R1. So R1 value is equal to 10 kilo ohms, RF value is equal to 100 kilo ohms. Let us now first find out the closed loop voltage gain. So what is the formula for closed loop voltage gain? We already know it. AF is equal to 1 plus RF upon R1 for a non-inverting amplifier. So RF value is 100 kilo ohm, R1 value is equal to 10 kilo ohm. If we substitute these two values, the answer whatever we get is AF. So AF is equal to 11. We have already got this. Now AF value is known, V0 value is already given. So we should now calculate the value for input voltage, which means AF is equal to V0 upon Vi is our formula. What is Vi is equal to? Vi is equal to V0 upon AF. So what is the value for V0 they have given? V0 value they have given is 4 volts, which is come here. What is the value for AF that we have got? It is 11. So now 4 volts upon 11 will give us 0.364 volts, which is nothing but the answer for Vi. These are the simplest numericals in which you are just supposed to put the values and get the results. So you can solve more of these by taking the imaginary values of yours and get back to me if you get any doubts.